Let's go ahead and now look at oftentimes you're given a function and you're asked to find the domain of the function. So for instance, let me just write down 3 different functions, or maybe 3 or 4. How about oh no, I don't want, yeah, it's fine. Maybe one more. So actually I wrote down just 4 sort of random functions. F of x equals 2x minus 5, f of x equals square root of x plus 2, f of x equals x over x squared plus 5x plus 6, and then f of x equals square root of x minus 1 over x squared minus 16. So these sort of get maybe a little bit progressively more complicated. And now, eventually what we're going to do is we're going to look for the domain of each of these functions. Now just so you know, in the next video, we're going to begin to look at graphs of functions, and you'll see in the next video that we'll look at some graphs, and then we'll be asked to find the domain of the function based upon looking at the graph. And you'll find out that that's pretty easy, but in this case, we're asked to find the domain of these functions, and all we're given now is like an equation. So right now we're going to talk about how to find the domain of a function when your function is just the equation. The next video we'll talk about when you're given the graph how to find the domain. But for now, we're just given this equation. Now, the way I like to explain domain, let's first define the domain. The simple way I define the domain is all the possible values of x. Let's just look at this first function. So let's think about that. This seems like sort of a strange idea, but basically it's saying, okay, if I'm looking for the domain of this function, my question is, what numbers, what values could x be in this function and everything will be okay? In other words, is it okay for me to plug in x equals 1 into this equation? I mean, it seems like sort of a strange question, because obviously if I said x equal to 1, I would have 2 minus 5, the function would equal minus 3, right? So it's almost like, you know, is it okay to have a function equal to minus 3? It's okay. You know, how about, is it okay for x to equal 5? In other words, can I plug in 5 for the x and have my function have it be okay? Now I agree, even asking the question is sort of strange, Because yes, if I plug in 5 for x, I get 10 minus 5. The function is 5. That's perfectly fine. And you may be thinking to yourself, this is sort of a strange concept, because basically you may be thinking, or let me turn it around, and maybe a better question is to say, is there some number that x cannot be? Is there some number that if I put the number in for x, I somehow break some kind of math rule, or I do something that I shouldn't do? And in this case, there's actually not. I mean, in this case, x can be any number. X can be a negative number. I could set x equal to minus 10. It's okay. It would equal like minus, 25? I could set x equal, I can make x a fraction. I can make x a decimal. There's no limit to what x can be. As a matter of fact, let me point out to you this very important idea. Here's what I do. Whenever I'm given a function, and the function's an equation, and I'm asked to find the domain, what I call the default domain, in other words, my starting point for the domain, my starting point is to say, this is an interval. I'm going to start by saying the domain is negative infinity to infinity, which is another way of saying all real numbers. So here's what I do. When I'm given a function as an equation as a function, I'm asked to find the domain. Here's my starting point. I'm just going to assume from the start that the domain is all real numbers, because that's always a very good place to start. As a matter of fact, for this function here, I'm giving this function, I'm going to assume to start with the domain is all real numbers, and as it turns out, that's what the domain is. It's all real numbers. As a matter of fact, you may be thinking, so when is the domain, when is it ever not all real numbers? And there are actually only two exceptions to what I call the default domain. The default domain is the domain is all real numbers. There are actually only 2 times when that is going to change. And the first exception, the first time that the domain is going to change or be affected, is if you ever have your variable under a square root. What does that mean? That means if I'm ever given a function like this, say my function is 2 times the square root of x minus 1. My first initial domain, I'm going to assume, is all real numbers. And then I look and I say, but you know what? I actually have a variable under a square root. This is now going to affect my domain. My domain is not going to anymore be all real numbers, but this is going to change the domain. And I will show you in a minute how the domain is changed when you have a variable under the square root. So here's what happens. You're given an equation. You're going to assume the domain is all real numbers, and then you look to see if you have the two exceptions. The first exception, you see if you, in your equation, if you have a variable under the square root. And then the second thing you look for, you see if you have a variable in the denominator of a fraction. In other words, say you were given this function, what I suggest you do is whenever you're given a function, you initially assume the domain is all real numbers, and then the only thing that's going to change that, the two exceptions are if you have a variable under a square root, which we don't have, but the second exception is if you have a variable in the denominator of a fraction, which we do have. So right now, the domain for this function is not going to be all real numbers. It's going to be affected because I now have a variable under or in the denominator of a fraction. So just to review, in terms of the concept, whenever you're asked to find the domain of a function, and your function is an equation, the first thing you do is you're going to start out just assuming the domain is all real numbers, or the way we write that as an interval is negative infinity to infinity. That's our starting point, and then we go looking to see if we have either or both of these exceptions. And if we have these exceptions, then the domain is going to change. So let's go ahead and see how the domain changes based upon having these exceptions. So first of all, let's say we're given this function. What I told you to do is when you first start out, assume the domain is all real numbers. In other words, the domain is everything. And then I look for my exceptions. And lo and behold, I have one of my exceptions. I have a variable under the square root. So this domain now is going to change. So let's think about this. What is the concern? What's the problem with having a variable under the square root? Is there some number that if I plug in for x, that it's going to be a problem, or I break some rule in math? Think about it. Is there some special rule in math that involves a square root? And there is. If you remember, you cannot have a negative number if you remember, you can never have a negative number inside the square root, right? Square root of 9, if you recall, square root says go find a number that you can multiply by itself twice, it equals 9. It would be 3. However, what about the square root of negative 9? And we talked earlier, what do we call this? This would end up being a complex number. It's not a real number. In other words, we cannot take the square root of a negative number. So this becomes a problem. So what does that mean? It's undefined. Now if we wanted to, we could turn it into a complex number. We're not working with complex numbers here now. We're working with all real numbers. So what do you do? How does this affect my domain? What has to occur? Basically, you know what I want to happen? I need to make sure that the stuff under the square root is a positive number or 0. Right? The stuff under the square root must be positive, or it's okay if it's 0. But it has to be a positive number or 0. So for this example here, how do I determine? So it's like, okay, how can I make sure? How can I determine which x's don't break that rule? What I'm going to do is I'm going to take whatever's under the square root, and I'm going to say, you know what? You know what I'm really saying? I'm really saying x minus 1, all the stuff under the square root has to be greater than or equal to 0. In a sense, this is a way to express this idea that the stuff under the square root has to be positive or 0. Right? X minus 1 greater than or equal to 0 is a way of saying this thing has to be positive or 0. And then I just solve this inequality. So what I'm saying now is, if I want to make sure I don't break any sort of math rules for this square root, I've got to make sure x is greater than or equal to 1. In other words, if x is 2 or 5 or 10 or 20, I'm okay. However, if x is -1 or -5 or 0, then I got a problem. Let's express this as an interval. X greater than or equal to 1. 1's right here. So you know what I'm saying? This actually now becomes my domain. Remember what domain is? All the possible values of x. The domain is all the numbers that x can be, and everything's okay. That's what we're saying here. Okay, because of this square root up here, I've got to make sure if I want everything to be okay, I can only choose values for x that are greater than or equal to 1. Because when I do that, I end up with a positive number in the square root. What I can't have, I can't choose numbers where x is less than 1. Why? Because when I do that, and I plug it in here, I end up with a negative number under the square root. So for this equation, square root of x minus 1, I say the domain is bracket 1 to infinity. In other words, the domain, meaning what values can x be? For this equation, for this function, x can be from 1 to infinity. Another quick example. What if I was given this function and I was asked to find the domain? Once again, if I'm given an equation, my default, my starting point for the domain. I say to myself, I've got an equation. I'm going to assume, to start with, the domain is all real numbers. And then I go see if I have one of my exceptions. And lo and behold, I do. I have a variable under the square root. So what do I have to do? I have to see how this variable under the square root affects the domain. It's funny how this 5 here, I don't even care about this 5. All I care about is the stuff under the square root. And I simply have to make sure that everything under the square root is greater than or equal to 0, which means everything under the square root has to be a positive number or 0. Now I'm going to solve this inequality, which means get x by itself. So I'll subtract 4 from both sides, divide both sides by 2. Basically, I'm saying, hey, for everything to be okay, x has to be greater than or equal to -2. And just to make it very clear, if I graph this, x greater than or equal to -2, if -2 is here, in a sense, that's my domain. In other words, these are the numbers I can plug in for x, and everything will be okay. So I would say the domain equals, as an interval, -2 to infinity. Just for fun, let me do one more, because those two sort of look the same. I'll do one quickly. How about f of x equals square root of 1 minus x. I want to find the domain. Starting point is, I assume the domain is all real numbers. And then I check, and lo and behold, I have a variable under the square root. So now my domain is going to change. I'm going to take everything under the square root and say, has to be greater than or equal to 0. I'm going to solve this inequality. Subtract 1 from both sides. I've got -x greater than or equal to -1. I want this to be x, so I'll divide both sides by -1. However, remember, whenever you divide both sides by a negative for an inequality, the inequality flips. So now, I'm saying that x has to be less than or equal to 1. Just to make it very clear, I always graph it. So if 1 is here, x has to be less than or equal to 1. Looks like this. So this becomes my domain. And in this case, the domain would be -infinity to 1 with a bracket. In other words, what can x be? X can be any number between -infinity and 1, because when x is equal to something in here, I end up with a positive number under the square root. All right, hopefully you get that. So this is the first exception. Way back when I said what we're going to do when we're given an equation, and to figure out the domain, we assume the domain is all real numbers, and then look to see if we have one of these exceptions. The first exception, variable under the square root. So we see how that affects the domain. But the second exception is you have to look to see if you have a variable in the denominator of a fraction. So say you're given this function, (5 over x plus 2). You're asked to find the domain. Okay, since I have an equation, the starting point for my domain, I'm going to say it's all real numbers. And then I look to see if I have either of my exceptions. And lo and behold, I do have one of my exceptions. I have a variable in the denominator of a fraction. Let's think about this. What's the big concern? What's the thing I have to watch out for, the thing I have to avoid whenever you have a variable under a fraction? What can you not ever have when you have a fraction? Well, if you remember, you can never have the denominator equal to 0. That's one of those math rules. You never, ever, ever can have the denominator of a fraction equal to 0. So if I look up here, then I have to ask myself, all right, well, what value of x would cause this denominator to 0? In a sense, what I'm saying is I need to solve this little equation, and when I solve it for x, that is what I know x better not ever be equal to. So in this case, it's pretty obvious. I solve this equation, x is minus 2, which in a sense, you know what I'm saying? I look at this, you know what I'm saying? I'm saying, you know what? I don't even need to do this equation here. This one's simple enough. I could have just looked at it and said, you know what? What value of x is going to be a problem? I'm going to say x better not ever equal negative 2. Because if x equals negative 2, if I plug in negative 2 for x, negative 2 plus 2 is 0. I've got a 0 in my denominator. I can't have that. So, how does this work? I'm given this function. My initial domain, I say to myself, is all real numbers. And then, because I have a variable in the denominator, I say, but you know what? Here's an exception. Even though I initially said the domain can be all real numbers, it cannot. X cannot be equal to 2. So really, what I could say the domain is all real except negative 2. In other words, x can be anything except negative 2. Now, if I were to write that as an interval, there's actually two ways they write it. They may have you write it like this, x such that x. This is a way to say x is everything but negative 2. If they write it as an interval, you would say start at negative infinity and you go up to 2. If you think about let me not do that, it's confusing. Here's what it is. Let me just explain it. It's like I union two intervals. Right? My domain can be any number less than 2 or any number greater than 2. What it can't be is 2. So this is a way to draw my graph to leave out the 2. And this is a way to write the interval. Negative infinity to 2, union with 2. It's almost like I have to skip the 2. My domain is everything on both sides of the 2. How do I skip the 2? I union this interval with this interval. So it's pretty easy to see when you look at this function right away. You just say, you know what? I got to make sure I know that x can never be equal to 2, and you go from there. Let's do a couple other examples. And actually, well, let me just What if you're given this function and you're asked to find the domain? Once again, anytime you're given a function and it's an equation, the starting point is the domain. I'm going to say is all real numbers, and then I look to see if I have either of my exceptions. And in this case, I first look for a variable under the square root. I don't have that. But then I look for a variable in the denominator, and I do have that. So now I realize my domain is going to change. And what's the idea? I've got to make sure that this denominator can never equal 0. And sometimes what I have to do is, in this case it's true, in order to figure this out, I actually need to factor this. This is a difference of squares. So when I factor it, I actually end up with x over x plus 3 times x minus 3. So now, once again, my main concern is I've got to make sure the denominator never equals 0. Well, if I look at this first parenthesis, if that first parenthesis equals 0, then the whole denominator is 0. What value of x would cause this first parenthesis to be 0? -3 would, right? So I've got to make sure, I've got to say x can never equal -3. And if I look at my second parenthesis, what value of x would cause the second parenthesis to be 0? X equal to 3. All right, in a sense, I say x cannot be equal to 3. So basically I'm saying, when I look at this, x can never equal -3 and 3. Now in words, I can now say, so what's my domain? My domain would be all real numbers except -3 and 3. I think maybe in math, sometimes the way they like to write that is the set notation, which I showed you before, which means the domain equals x such that x, and what you do with this notation is when you write x cannot be equal to -3 and 3, this basically is a way of saying that the domain is all real numbers except -3 and 3. All right, so now, as a quick review, when we look at domains of equations, we assume the domain to start with is all real, and then we look for the two exceptions. The one exception is variable under the square root. The other exception, is the variable in the denominator of a fraction. And now we realize the impact that both of those situations have on the domain. Now, as one final, if I go back, here are the initial functions I gave you. What's the domain of this first one? To review, once again, it's actually all real, right? Because there's no variables under the square root, no variables in the denominator of a fraction. The domain is all real numbers. For this one, I would have to go figure out how this variable under the square root affects it. This one, you notice I have variables in the denominator. I have to go worry about that. But look at this last one. Let's go and do this last one, because we haven't talked about this yet. So let me copy this down. What if you're given this function and you're asked to find the domain? So once again, the starting point is you say, well, I'm going to assume the domain is all real numbers, and then I'm going to see if I have either of my exceptions. So in this case, I look and I say, do I have any variables under the square root? Lo and behold, I do, so I know my domain's going to change. But then I say, and what about my second exception? Do I have any variables in the denominator? And I have that also. So here's a case I actually have an equation that has both exceptions. So we've looked at examples when I have one or the other, but what would the domain be if actually I have both exceptions in the same equation? All right, let's look at that. Here's what I like to do. First, I'm going to analyze the impact of the variable under the square root. So let's just do that. I know what has to happen is I have to make sure that everything under the square root is positive or 0. So I say x minus 1 greater than or equal to 0. I'm going to solve this thing for x. Matter of fact, I'm going to go and graph it. So far, this is my domain. So it's almost like, so my domain has now changed because of the square root, such that my domain is now from 1 to infinity. Of course, this new domain is now the result of the impact of having the square root. But now, I have to also take into account that I've got a variable in the denominator. Now actually, let me show it over here. I need to factor the denominator. Once again, it's a difference of squares. And now I say, if I look at that denominator, what do I know that x cannot be equal to? X cannot be equal to negative 4 or 4. Now if I take this information and go over here to this graph I created, well, if I look and graph negative 4 and 4, well, maybe negative 4 is way over here. And you know what? Negative 4 has been excluded. Negative 4 is not in the domain because of the square root. In other words, negative 4 has already been eliminated. I don't have to worry about it. It's not a problem. However, when I go look at 4 is like right here. The point being, if it's up to the square root, x equal 4 is no problem. It's perfectly happy to have x equal to 4. So I'm not going to break any rules from the square root part. However, the denominator says, but wait a second, x cannot be equal to 4. Even if it doesn't cause a problem for the square root, I know that x cannot be equal to 4. So in a sense, what my graph now has to change, it's almost like I start at 1, then I go to 4, I have to stop because I cannot include 4 in my domain, and I have to, in a sense, sort of skip or hop over 4 and then keep going. So if I write that as an interval, I have to union these two intervals. I start at 1, I go to 4 with a parenthesis, and then I have to skip or jump over 4, whoops, and then I union it, I start again at 4, and go on to infinity. So for this function here, where I have both variable under the square root and variables in the denominator, I first take into account the impact of the square root, and then I look at the impact of having the variable in the denominator. When I combine those, I end up with this domain. All right, I spent a lot of time, but I know a lot of times students can be confused about finding the domains of functions written as equations, so hopefully that'll make it very clear.